This conference will now be recorded.
I think we are good to get started, right? So let's start. Hey guys, this is Vamsi Krishna here. So I'll be your trainer for Big Data and Hadoop. So this training is driven towards 45 hours, and we'll try to understand the agenda for today, and then we'll try to go step by step, right? So that's going to be our plan for today. So first, we will try to understand why Hadoop is in huge demand, and then we'll understand what is big data and what are the sources of big data. Then we'll understand what are the categories and characteristics of big data, and we'll make an important comparison of the traditional RDBMSs with Hadoop. Then we'll take it one level deeper. We'll understand what is Hadoop and its history and the architecture of Hadoop, and what are the important core components that are involved in Hadoop. And then we'll understand how to make the Cloudera Quick Start VM setup so that we can start our hands-on sessions right from day one. So this is going to be our agenda for today. So we'll go step by step, right? So first, we'll try to understand why is it a good idea to learn Hadoop. Again, this is coming from Forbes. Forbes claims that by 2022, we can see the Hadoop market costing $99.31 billion. And in fact, Payscale.com claims that the salaries of Hadoop professionals would be varying around $93K to $127K. Even IDC claims that by 2024, we could see the Hadoop market crossing $210 billion. So these are some of the staggering numbers because of which we could clearly say that there is huge demand for Hadoop. And in fact, if you see the annual salary of Hadoop employee in United States, it's around $112,000, which is almost 95% greater than the salaries of all the other job postings, right? And if you compare Hadoop with other technologies, you could see Hadoop is the leading technology with respect to salaries. That you could see the salaries are being, it's actually very high compared to other technologies. Other reason to learn Hadoop is there is shortage of skilled professionals in the industry right now, and actually you are learning the technology at the right time, at the right point. You are making a step into Hadoop, and also there are a lot of unfilled jobs yet to be filled in the big data world. The boom for big data is going to grow even in the coming years as well. So that's for sure. So this is with respect to how Hadoop is doing in the market. Now we are going to go into the actual technical details with respect to big data and Hadoop, right? So just to clarify, you guys can hear me and see the screen clearly, right?
Yes.
Good. Yeah, now we are going to the actual technical details now. So right now we are in 2020, and we'll try to understand what are the sources of data. Again, when I say sources, it is nothing but where is this big data coming from, right? And as you know, 1 minute is nothing but 60 seconds. Within a span of 60 seconds, there are a lot of things happening all over the internet. That is, if you take Facebook, Facebook claims that there are 973,000 logins are being happening, and even Google claims 3.7 million queries are being searched, and even WhatsApp claims 38 million messages are being transferred. Similar is the case with Instagram, and many apps are being downloaded from Play Stores and App Stores. Even YouTube claims 4.3 million videos are being watched. So these are some of the staggering numbers because of which we could clearly say that the big data is going to grow even in the coming years as well, right? Now let us talk about the formal definition of big data. What is big data? And as you might guess easily, big data is nothing but huge amount of the data. It is nothing but the huge amount of the data which cannot be stored or processed by the traditional RDBMSs such as MySQL and Oracle. And interestingly, 90% of the data that's available on the earth has been generated in the past few years. And as a big data and Hadoop developer, an important responsibility is to talk to multiple teams on daily basis. And all the talk happens in terms of data. And as you know, data is measured in bits and bytes. So before we move forward, let us try to have a clear understanding about the memory capacity conversion chart. So 1 byte is nothing but 8 bits, and 1 KB is nothing but 1024 bytes, and 1 MB is 1024 KB, and 1 GB is 1024 MB, and 1 TB is 1024 GB. Now the question is, when can we say that we have got a big data problem? When the data that is getting generated is crossing the limits of TBs. So if the data is getting generated in terms of petabytes or exabytes or zettabytes or yottabytes, that is typically considered to be the big data problem, right? Now we are clear with what is big data, right? Now let us try to understand the categories in big data, or some people even call it as different forms of big data, right? So there are three categories in big data. One is structured data, second one is unstructured data, third one is semi-structured data. So the first one is structured data. As the name suggests, the data will have a proper structure. That is, if we take the tables in an RDBMS, how do they look like? The tables in an RDBMS will have proper structure, right? They'll have horizontal ones, which are nothing but the rows, and the vertical ones, which are nothing but the columns. So the tables in RDBMS is a typical example for the structured data. Coming to the next one, which is nothing but the unstructured data. As the name suggests, they don't have any proper structure at all. So I wanted to take some examples here. So I see that CC cams are being installed everywhere these days, be it houses or offices, everywhere I see CC cams. So what's the main purpose of installing CC cams? Just to monitor something, right? Again, these CC cams generate huge amount of the videos. So videos would fall into the category of unstructured data. And as a part of communication in offices, we typically use mails, right? So mails is another example for the unstructured data. And if you have the habit of listening to FM, what do these FMs generate? These FMs generate huge amount of the audios, right? So audios also would fall into the category of unstructured data. Coming to the third category, which is nothing but the semi-structured data. As the name suggests, it would fall in between structured and unstructured. It will have a kind of semi-structure. A very good example for semi-structured data could be the XML data. XML stands for Extensible Markup Language. Another example of semi-structured data could be the JSON data. JSON stands for JavaScript Object Notation. JavaScript Object Notation. Again, don't worry about these terms. We are going to talk about all these with respect to hands-on, right? Now, just to give you a nutshell idea about the categories of big data, there are three categories of big data: structured data, unstructured data, and semi-structured data. Now we got a fair idea about what is big data and what are the categories of big data. Let us try to understand the characteristics of big data, or even some people call it as 3 V's of big data. The first V is nothing but variety. Variety refers to different forms of big data. Again, the data that is getting generated could be the text data or sensor data or documents, images, audios, or videos. If you take any of this, everything would fall into one of the three categories that we have just discussed in the previous slide, right? So variety refers to different forms of big data. And coming to the next V, it is nothing but the velocity. So velocity is nothing but the speed at which the data is being generated. Here I want to take some examples. So we use social messaging apps on daily basis, such as Instagram, Facebook, WhatsApp, Twitter, Telegram, etc. Right? So knowingly or unknowingly, we post something, right? We post something. Some do it on minute basis, some do it on hourly basis, some do it on daily basis, some do it on weekly basis. But somehow or the other form, or directly or indirectly, we are generating some huge amount of the data, right? So velocity refers to speed at which the data is being generated. Coming to the third B, it is nothing but the volume. So volume refers to quantity or size of the data that is being generated. Again, the generating data could be in megabytes, gigabytes, terabytes, or petabytes, right? So volume refers to quantity or size of the big data that is getting generated. So big data is a combination of all these three V's put together: variety, velocity, and then volume. Now we are clear with the characteristics of big data. Let's try to answer this simple question. What is the solution for big data? So we are pretty much clear that big data is a problem that we have got, right? And for every problem in this universe, there must be a solution, isn't it? The solution to deal with the big data problem is nothing but Hadoop. In a nutshell, big data is a problem that we have got, and Hadoop is a solution to deal with the big data problem. Now, you must be still wondering, why do we need to learn a new framework called Hadoop? Can't we just use the traditional RDBMSs? That's a very valid question and very important from the entire perspective as well. We are going to answer that question right now. So we are going to consider some of the important points while making this comparison of traditional RDBMSs with Hadoop. So the first point is nothing but the storage limit. In the traditional RDBMSs, such as MySQL and Oracle, there are certain storage limit constraints. Beyond that limit, you can now store huge amount of the data, right? On the other side, Hadoop can store as much data as it can. There is no storage limit constraint at all. That is the biggest advantage with respect to Hadoop, right? Coming to the next point, varieties. In the traditional RDBMSs, we can store only the structured data. We cannot store unstructured or semi-structured data. On the other side, Hadoop can store structured, unstructured, as well as semi-structured data. Coming to the third point, cost of the software. So let us say that I'm working on some traditional RDBM system. So what is the first thing that I should do? I should buy a licensed software, right? I should buy a licensed software by paying huge amount of the money. Not only that, I have to renew the license of the software every few years so that I can work on that continuously without having any breaks or without having any hurdles in between, right? So there is a lot of money involved both to buy the software as well as to maintain it. That is going to increase the cost of the project, right? That's where Hadoop comes into the picture, because Hadoop is absolutely free. You don't need to pay anything to anybody to start using Hadoop. Coming to the fourth point, which is very important point, I'm going to take an example here. Let's say that I'm storing the details of all the citizens from all over the world. It includes the citizens from all the countries such as US, UK, China, India, Japan, etc. Now my goal is to retrieve the citizens who belong to US. So that's going to be my simple query, right? Now how do my query would look like? Imagine that I'm storing all these details of citizens in a table called citizens. Now my query would look something like this. Select star from citizens where location equal to US, right? So that query is going to work in a sequential way, right? Because it's going to go record by record, it's going to go row by row, it's going to check the location field of that particular record. If it belongs to US, then only it's going to gather all those records. Again, remember, it's not going to display the results immediately. It's going to go through record by record from the first record to last record of the table. It's going to check record by record sequentially or serially it's going to check the location field. If the location field matches with US, then only it's going to gather all those records. And it's going to display the results only after processing the last record of the table. But the problem is we are dealing with huge data, right? First of all, we cannot store such huge data in the traditional RDBMSs, but somehow even if you store it, this query is going to take longer time, at least 4 or 5 days of time to see the results because the data is so huge, right? And also it is working in a sequential or serial fashion. Now that's where the traditional RDBMSs are going to fail because they are going to have a lot of performance impacts because of which the data processing will take longer time. Now on the other side, Hadoop works in a smarter way. It is not going to store the data on a single computer. It is going to store the data across multiple computers. That is what is called distributed storage. On those respective machines, the data processing happens, right? Again, we are going to talk about that in depth today, but just to summarize about the fourth point, the traditional RDBMSs work in a serial or sequential way, which will have a lot of performance impacts. On the other side, Hadoop works in a parallel way or in a distributed way, which is going to give you better performance compared to the traditional RDBMSs. Coming to the fifth point, the cost of the hardware. Again, to handle the client requests in traditional RDBMSs, we need to buy high-end servers. Again, to buy high-end servers, that's going to increase the cost of the project, right? And on the other side, Hadoop can be built upon a commodity hardware. That is, what is commodity hardware? Commodity hardware is nothing but the non-expensive hardware. So that is, we can build Hadoop clusters even on the non-expensive hardware as well. It's going to work pretty much fine. And the last and important point is source code. Imagine that I'm working on some traditional RDBM system. For some reasons, I'm facing some stability issues. That is, probably it might be working very slow, right? Now, what are the options that we are left with? All we have to do is to wait until the next version of that particular traditional RDBM software comes into the market, isn't it? But on the other side, Hadoop is completely open source. That is, you don't need to pay any money to anybody, and the source code is available for free, right? And what you can do is you can play with it, you can customize it, and you can modify it as per your need. So after comparison of all these important points, I would clearly say that Hadoop is a clear winner over the traditional RDBM systems. In fact, this question is very, very important from the interview perspective. If you can explain this by considering 2 or 3 points, that should be more than enough in the interviews, right? So now we are pretty much clear with why do we need Hadoop, and we made an important comparison of traditional RDBMSs with Hadoop. Now let's go further and try to understand the history of Hadoop, how Hadoop came into the world. So Doug Cutting is the founder of Hadoop technology. So way back in 2003, as you know, Google is a very popular search engine, but in 2003, Google had a tough time because it was unable to store all the queries that were searched by the users in the search engine, in their search engine. So that's when in 2003, Doug Cutting published a white paper called GFS, which basically stands for Google File System. And this is the solution to the problem that Google was facing. So this is the place where all the queries were stored. And it eventually spanned into other paper in 2004 called MapReduce. So MapReduce is the data processing layer. That is, whatever data that has been stored on GFS can be processed with the help of MapReduce. And interestingly, this name Hadoop has come from his son's Toilfint name. Doug Cutting's son's Toilfint name is called Hadoop. So that's where he named this technology as Hadoop. And that's the reason why you would see a small elephant.
Thank you.
Hey guys, any questions? Anybody have any questions?
No.
Okay, we are good,
No.
right? Okay, cool. Okay, so that's the reason why you would see a small elephant everywhere you see this term called Hadoop, right? Now, this is the history of Hadoop. Now let us talk about what is Hadoop. So as I told, Hadoop is an open source project coming from Apache Software Foundation. And many people have misconception these days that Hadoop is a programming language. No, Hadoop is not a programming language. Hadoop is a software framework meant for distributed storage and distributed processing on a cluster of servers. So what is a cluster? Cluster is nothing but group of computers or group of machines connected together. That's what is called a cluster. And in fact, Hadoop took the inspiration from Google file system as well as from its MapReduce programming model to come into the market. And remember that Hadoop was not the main project when it started. Hadoop was a sub-project of another search engine called Nudge. So there used to be a search engine called Nudge. So Hadoop was a sub-project of Nudge search engine project. But gradually, Hadoop gained the popularity, and even when duck cutting moved from Google to Yahoo, it's completely open source and it's completely written in Java. But just to give you an idea, as a part of our learning or as a part of our training, we are going to use something called Spark, because Spark is the latest data processing framework that's very popular in big data and Hadoop world. And we are going to use a programming language called Python. And first we'll learn Python in depth, then we'll learn Spark in depth. So that's going to be the idea. Okay, anyways, Hadoop efficiently processes large volumes of the data on cluster of commodity hardware. So let us try to decode this statement. We are talking about cluster, which is nothing but a group of servers or computers, and they are made up of commodity hardware, which is nothing but non-expensive hardware. So even on the non-expensive hardware as well, we can build our Hadoop clusters. And see here, Hadoop can be set up on a single machine. So today I will walk you through step by step how to set up Hadoop on your laptop. But the real power comes with cluster of machines. Again, as we progress through our training, we are going to talk about AWS, which is nothing but Amazon Web Services, and we are going to build multi-node AWS EMR cluster, that is AWS Elastic MapReduce cluster, and we are going to deploy our project on Spark onto AWS EMR multi-node cluster. So that's going to be the idea. And in fact, just to give you an idea, if you have the skill set of Hadoop, Spark, and then AWS, this is a very, very hot skill currently in the market. So we're going to learn all those, so that you are going to be market ready once you finish the training, right? So before going further, I have a simple and interesting story for you. So there lived a king in a kingdom. One fine day he wanted to find out how many people are living in the kingdom. That's when he called his minister to figure out the number of people living in the kingdom. Now minister just obeyed king's order. He said that he's going to figure out the number of people living in the kingdom. So he went alone to figure out the number of people living in the kingdom. Remember an important point, that minister went alone to figure out the number of people living in the kingdom, right? Of course, as he went alone, he took a lot of time to figure out the number of people living in the kingdom, and the king is absolutely not happy, because the reason is he got to know the count from the minister after a long period of time. That's why king is absolutely not happy. Now king suggested to minister to take help from other soldiers as well while going for the count next time. Now minister just obeyed king's order again, so he went to the kingdom for the count this time. This time he went along with the soldiers as well. As he went along with the soldiers, he finished the given task within short period of time. Even the king is absolutely happy, because he finished the given task within short period of time. Now if you closely observe the first approach, where minister went alone to figure out the number of people, it can be compared with the sequential or serial crossing model on which the traditional RDBMSs are based upon. They have a lot of performance impacts, right? On the other side, where minister went along with other soldiers as well, that can be compared with the distributed or parallel processing model in which our Hadoop systems are based upon. In fact, Hadoop is nowhere different. It's very close to this concept, because even in Hadoop also we have got something called master, which can be compared with the king, and we have got bunch of slaves which can be compared with the soldiers, and we have got secondary master which can be compared with the minister. So Hadoop is based upon master slave architecture. That is, whatever master says, slaves will just obey and do it for the master. That is, whatever king orders, soldiers are going to do it for the king, right? And Hadoop architecture is based upon distributed storage. That is, we are going to store the data across multiple computers. That's what is called distributed storage. And on those respective machines, the data processing happens. That's what is called distributed processing. And this whole block is called as Hadoop cluster. This whole block is called as Hadoop cluster. In a nutshell, Hadoop is based upon master-slave architecture with distributed storage and distributed processing. Now there are some technical terms to these. So the technical terms to these are nothing but master is called as name node NN, and secondary master is called as secondary name node SNN, and slaves are called as data nodes DN or worker nodes WN. So I am going to use these technical terms going further today. So I wanted to repeat it once again. So master is called as name node NN, and secondary master is called as secondary name node SNN, and slaves are called as data nodes DN or worker nodes WN. Now, having understood these terms, let us try to understand the core components in Hadoop. There are two core components in Hadoop. One is called HDFS, then the other one is called as MapReduce. So in HDFS, or what is the full form of HDFS? HDFS stands for Hadoop Distributed File System. So this is the place where all the big data is stored. So this is the storage layer in Hadoop. And whatever big data that has been stored on HDFS, it can be processed by using MapReduce, right? So in a nutshell, HDFS is the storage layer and MapReduce is the data processing layer. And Hadoop is always a combination of these two core components put together. Now we are going to learn in brief about each of these core components so that we'll have clear-cut understanding. So the first one is HDFS. HDFS stands for Hadoop Distributed File System. So this is the distributed file system because the data won't be stored on a single machine. Data will be stored across multiple machines. That's why it's called a distributed file system. Again, remember an important point, guys. So whenever we talk about data in Hadoop, we are always going to deal with multiple copies of the data. We will never deal with a single copy of the data. And Hadoop stores all the data on the slave machines or on the data nodes or the worker nodes. All the data is stored on the worker machines or data nodes. And the scenario is I have a huge file, or I would say that that's a big data file, and I'm going to break that big data file, or I'm going to split that big data file into small parts. I'm going to break that file into small parts. Each small part is called a block. Each small part of the file is called a block. And these blocks are stored across multiple data nodes, that too by maintaining multiple copies of each block. Now, why are we maintaining multiple copies of each block? So there is a very good reason behind that. I'm going to cover that shortly. But for now, just remember that we are always going to deal with multiple data nodes and that too multiple copies of each block. There are two versions of Hadoop now. One is Hadoop 1.x, then the other one is Hadoop 2.x. In Hadoop 1.x, the default block size is 64 MB. In Hadoop 2.x, the default block size is 128 MB. Now, let us perform the live task so that we'll understand how these blocks are getting created internally. So imagine that I have this file which contains the employee details such as employee name, employee location, and then employee ID. And this file is of size 260 MB. Now my goal is to understand how many blocks can be created from this file of size 260 MB. Now the first question that should come to your mind is which version of Hadoop are we using? Imagine that I'm using Hadoop 2.x. So what is the default block size in Hadoop 2.x? It is nothing but 128 MB, right? So it is 128 MB. So we are going to divide 260 MB by 128 MB. Again, What is 260? 260 is nothing but the and 120 is nothing but the default block size in Hadoop 2.x. So what is 260 by 128? It's going to be 2 point something. So it's a clear indication that there will be two full blocks. That is, I'll have block 1 and I'll have block 2. So I'll have block 1 of size 128 MB, right? And I'll have block 2 of size 128 MB again, because we are getting the output as 2 point something, right? So it's pretty much clear indication that I'll have two full blocks. What that is block 1 and block 2. They are going to be of maximum capacity of 128 MB. So if I add these two, 128 plus 128 is 256. But how much is my file size? It is 260 MB. So there'll be third block of size 4 MB, right? That's how these blocks are created. Now just a simple cross check whether you have done it correctly or not. If you add the sizes of all the blocks, it should be equal to your file size. That is 128 plus 128 is 256 MB and 256 plus 4 is nothing but 260 MB, right? So we have done it correctly, and in fact, to answer my question, it's going to create totally 3 blocks, out of which 2 blocks will be of size 128 MB and third block will be of size 4 MB. So that's how the actual block creation happens in Hadoop. Now we are pretty much clear with how the block creation happens in Hadoop. Now let's go ahead and understand an important concept in Hadoop called fault tolerance. What is fault tolerance? So again, imagine that I have this large file and I have broken this large file into small parts. Each small part of the file is called a block. I have 4 blocks: block 1, block 2, block 3, and then block 4. Now I'm going to store these blocks across multiple data nodes. That is, I have block 2 first copy, block 2 second copy here. I have block 3 first copy, block 3 second copy. I have block 4 first copy here. I have block 4 second copy here. Now, in order to process this large file, I need all the 4 blocks: block 1, block 2, block 3, block 4. But one day, the machine or the server on which this block V1 is there has gone down. Do you think we'll still be able to process this large file? Yes, we can, because we have got other copy of block B1 available on our other machine, which is up and running fine. So we are going to make use of that to actually process this large file, right? So that's how Hadoop has got the ability to tolerate the faults. That is, even though one of the machine has gone down, we still be able to process the data as if nothing has happened in the system, right? So that's why Hadoop is called as highly fault tolerant system, because it has got the ability to tolerate the faults. And this is the unique selling point and why Hadoop is so popular these days, right? So this is the key point with respect to Hadoop. The fault tolerance is making Hadoop popular. Now let us try to understand the other core component in Hadoop, which is nothing but MapReduce. So MapReduce is the data processing layer. The way it works is going to take the work and it's going to divide that work into small parts, and those small tasks would be executed independently in a parallel way. That is to make you understand even better. So I have this MapReduce program which is marked as MR, and I'm going to give this MapReduce program to the master machine in the cluster. Now master machine being the master, it has got complete idea about where the data is stored on the slave machines. Now what master is going to do is, the master is going to copy the same MapReduce program only onto the machines where the data is available. Again, remember, it's not going to copy the MapReduce program into all the machines. It's going to copy only onto the machines where the data is available in the form of blocks. Now, on those respective machines, the data processing happens, and finally the results will be sent back to the master machine, right? So that's how the MapReduce works. Now to put it all together, I have 4 steps for you. Step 1, step 2 belongs to HDFS, step 3 and step 4 belongs to MapReduce. In step 1, I have got my input data, or I have got my big data, which has been broken into small parts, right? So the small part of the file is called a block. And the block size can be 64 MB if you're using Hadoop 1.x. Block size can be 128 MB if you're using Hadoop 2.x. And once the blocks are created, all those blocks are actually moved to the all the blocks are stored on the different data nodes in the cluster. And then we'll write a MapReduce program, and actual data processing happens on those machines, and finally the results will be sent back to the master machine. This is what is going to happen in Hadoop, right? Now we are going to talk about Hadoop daemons, but before that, let us try to understand this term called daemon. What is a daemon? Daemon is nothing but a continuously running process. That is, as soon as you switch on your laptop,
I had
there
a
is some.
sorry.
Yeah, go ahead, go ahead.
Could
Please
you
go ahead.
go two slides?
Okay, 1 minute. I'm going back. Which one? This one?
No, one more.
This?
Yeah. So you said like the job will be sent to the machines where the blocks are, right?
Correct.
But you said also there'll be multiple copies of block one. So say if
Yes.
block one was on machine one and then machine three, both, or
Sorry, can you please repeat that question again?
so you see, you said there'll be multiple copies of the block, right?
That's correct. Yeah.
So say block one is in machine one where it is running, there's another copy in say machine four, just right between, right?
Okay.
MapReduce job be sent to both the machines or just one copy?
So it's going to take care of only one, any one of those copies.
Okay.
Yeah, that's how it works.
Okay, thank you.
So we were talking about Hadoop daemon. So let's go back there. Yeah. So what is a daemon? So I told that daemon is nothing but a continuously running process, right? So I want to take an example here. Let's say as soon as you switch on your laptop, there is something called task manager, right? So the task manager starts as soon as you switch on your laptop, and then the task manager will keep on running until you shut down your laptop, right? So the task manager can be considered as an example for your daemon process, right? We are clear with what is daemon now, and similar to this, there are 5 daemons in Hadoop, 3 in HDFS and then 2 in MapReduce. In HDFS, the master daemon is nothing but the name node, and the slave daemon is nothing but the data nodes. And of course, we have got other daemon in the form of secondary name node. Coming to the MapReduce, the master is called as job tracker, and the slave is called as task tracker. And of course, the HDFS is called a storage layer. In the storage layer, the master is considered to be the name node, and bunch of data nodes will act as slaves. And coming to the MapReduce, the job tracker will act as master, and bunch of task trackers will act as slave. Another question is, how are these allocated in the real-time projects? So generally in the real-time projects, we will have the master machine and we have bunch of slave machines. On the master machine, we will have the job tracker daemon and name node daemon running together. On all the slave machines, we have task tracker daemon and the data node daemon running together. So now the job tracker will be in touch with all the task trackers, and the name node will be in touch with all the data nodes in the slave machines. So that's how the actual allocation and then the communication happens among these daemons in the real-time projects. Now, let us talk about something called popular flavors or distributions in Hadoop. But before that, let us try to understand this term called flavor. What is a flavor or what is a distribution? In fact, this is going to be a definitive interview question in the interviews, right? So in almost all the interviews, you are going to expect this question, right? So first, let us try to understand what is a flavor or what is a distribution. So flavor or distribution can be compared with, let's say, I'm using iPhone, and iPhone has got the mobile operating system as iOS, right? And if someone is using Samsung smartphone, the Samsung makes use of Android as a mobile operating system. I think if someone is using Nokia, I think Nokia has got MS Windows as the mobile operating system. So what are these basically? These are nothing but the flavors or distributions in mobile operating systems. That is Android, iOS, etc. Right? So similarly, even in Hadoop also there are different flavors. They are called as Cloudera, Hortonworks, and then Mapper. So now today we are going to learn about how to set up Cloudera Quick VM on our laptop, right? So now to do that, we have got certain steps. So we are going to take. Give me 2 minutes, guys. Give me 2 minutes. Give me 2 minutes. Hey, sorry for the interruption. Anybody have any questions, guys?
Yeah,
No.
Vamsi, when we talk about these flavors, right? It can be considered something like Linux flavors we have, like Debian.
Yes, yes,
One.
correct, Anand. That's exactly correct. So what we do is in Hadoop, on Linux flavors, we are going to install Hadoop, right? You got it? Yeah. So we
Yes.
have flavors such as Debian, Red Hat, Fedora, etc. Right? On top of Linux flavors or Linux operating system, we are going to install Hadoop.
Okay. So Hadoop is a kind of a software, or how can we consider it? Like, how can we term it like?
Yeah, it's basically a framework or software using which we are going to install it on typical Linux machines.
Okay. Yeah.
We are good, right? There are no
Yeah.
questions. We can move on.
Yeah.
Yeah. So let's talk about how to set up Hadoop on our laptops. So to do that, we need to have something called Cloudera Kickstart VM. So what is a VM? VM basically stands for virtual machine. So what is a virtual machine? So virtual machine is nothing but a virtual computer. So what does your laptop have? So your laptop have hard disk to store the data, and you have got CPU for processing capability, and you have got RAM for main memory purpose, right? So it's even VM is also similar to that. Its only thing is it's just a virtual machine. So in Cloudera Kickstart VM, we have to download the Cloudera Kickstart VM and then we have to use it. So now you must be wondering, so okay, I would need virtual machine, but why do I need another software such as VirtualBox? So that is, suppose let's say if you want to listen to an audio song, that is MP3, typically the audio song format will be MP3. So to listen to this audio song, we need some sort of player, right? So we need some sort of player such as VLC media player or Windows media player, something similar to that, isn't it? So similarly, to use Cloudera Quickstart VM, we need to have some sort of virtualization software. It is nothing but VirtualBox. So now we are pretty much clear about why do we need two softwares to set up Hadoop, right? Now we are going to go step by step and we are going to understand how to download and how to install each of these. Again, I am going to share these slides after the session, guys, so don't worry about it. So you can refer to this slowly and then you can set up the Cloudera Quickstart on your laptops. So the first one is downloading VirtualBox. So just go to Google, type download VirtualBox and click on the first link, and then you should be able to go to this page. So if you're using Windows, click on Windows host. If you're using Mac, click on OS X host, right? So you could click on one of these two, depending on the operating system that you are using. So that is going to download VirtualBox. The installation is even simpler. All you have to do is to just double click on that VirtualBox software, click on next, and then it's going to get installed in your C drive under this path. But if you wanted to change it, you can do it. You can click on browse and select a different location, then you can click on next. So that's going to start with the installation process. It's going to install the desktop shortcuts. That should be fine. Click on next, and then it's asking final confirmation, proceed with the installation. Now click on yes. Once you click on install, that's going to start the installation process. After a while, you should be able to see that VirtualBox has been installed. Click on finish. That should finish the installation of VirtualBox. Again, it's very simple to install VirtualBox. Again, as I said, I'm going to share all these slides with you. You can refer these, then you can set it up. Now, the next step is downloading Cloudera Quick Start VM. So to download Cloudera Quick Start VM, just go to Google, type download Cloudera Quick Start VM. Click on the first link. You have to register with Cloudera to use Cloudera Quick Start machine, because it is similar to that. You have to register with Facebook to use Facebook, right? Similarly, we are going to register with Cloudera. Click on register button, enter the email address, first name, last name, click on submit. Then we are good to sign in. Click on sign in button, then enter your email address and then password. Click on sign in. Then from this drop down, you have to select VirtualBox. Again, remember an important point, guys. We are not downloading VirtualBox here. We are downloading the Cloudera Quick Start VM, which is compatible or which is suitable to work with VirtualBox. So select VirtualBox from this drop down, click on get it now, then accept the terms and conditions, click on submit. Now that's going to download Cloudera Quick Start VM for you. Once it has been downloaded, it should be something like this. Now it's the time to extract it. So how do you extract it? Just right click on it, click on extract. That's going to extract and it's going to show two software for you, right? These are the ones that we are going to use to set up Cloudera Quick Start VM. Now, once the Cloudera Quick Start VM has been extracted, it's the time to use the Cloudera Quick Start VM from the VirtualBox, right? So I'm going to click on file and I'm going to click on import appliance, and I'll click on this icon and I'll go to the place where I have extracted, and then I'm going to select this and then I'll click on open. Again, guys, don't worry, I'm going to share all these slides with you. You can refer this slowly and then you can set it up. So click on open, and then once you click on next, you should be able to enter the CPU and RAM details here, then click on import. Then after a couple of minutes, you should be able to see the Cloudera Quick Start VM available on your VirtualBox. Now to start it, just right click on it, do start and then do normal start. That's going to start the Cloudera Quick Start VM for you. So after 5 minutes or so, you should be able to see the Cloudera Quick Start VM up and running. Now let's say once you're done with the work for the day, if you want to power it off, you can go to the VirtualBox, right click on it, close, click on power off. That should take you to the powered off mode, right? So that's how you could set up Cloudera Quick Start VM very easily. Now let me summarize today's session. So what have we learned today? We understood that big data is nothing but the huge amount of the data which cannot be stored or processed in the traditional RDBMSs such as MySQL or Oracle. And also we have learned that big data is a combination of three V's put together, that is volume, variety, and then velocity. Big data is the problem that we have got, and Hadoop is the solution to deal with the big data problem. And Hadoop is a combination of two core components put together, that is HDFS and then MapReduce. And also in different versions, that is in Hadoop 1.x, we have got the default block size 64 MB. In Hadoop 3.x, the default block size is 128 MB. And with respect to the Hadoop daemons, there are totally 5 daemons in Hadoop. So 3 in HDFS and then 2 in MapReduce. In HDFS, the master is called as name node, and the other daemon in the form of secondary name node, and we have got slave in the form of data node or worker node. Coming to the MapReduce, we have got master in the form of job tracker, and then slave is nothing but the task tracker. And based on today's session, I have got 10 interview questions for you. So what I would suggest is go through this recording, then come back to the interview questions and then try to answer these questions on your own. Of course, I'll be providing the answers to these questions in a separate file so that you can cross-check the answers, right? And also, if our training goes for 30 to 40 days, I'll be giving you 10 interview questions on daily basis and 5 assignments on daily basis. So if it goes for 30 to 40 days, you'll be dealing with at least 300 plus different interview questions and along with 100 different assignments. So those must be enough for you to crack most of the interviews. And also, what can you expect at the end of this course? You should be in a position to become employable in the big data and Hadoop world. And this training is driven towards practical skills. That is, this is going to be 20% theory and 80% hands-on oriented training. We are going to work on multiple POCs and we are going to work on live projects which you can showcase in the interview, right? Which you can project in your resumes, right? And the specialty of this training is, as I said, is going to be pure hands-on driven oriented training. And what can you expect from me at the end of the session each and every day? You are going to get the recording of the session. You'll get the PPT that's covered in the session, and you are going to get 10 interview questions along with answers and 5 assignments along with answers. That will be approximately 300 plus different interview questions and 100 plus different assignments at the end of the training. And also, I'll be giving you, real-time interviews that were faced by my own students. So while they taking the interviews, they recorded it and they have shared all those real-time interviews with me. So there are around 20 plus interview recordings with me. So I'm going to share them at the end of the training, right? So they are going to definitely help you out so as to understand how the real-time interviews work. Also, I'll be taking you mock interviews and I'll give you some tips and tricks so as to understand how to answer the questions in the interviews, and that will definitely help you to crack most of the job roles. So that's all I have for today, guys. Anybody have any questions?
Hi, I just have a question where you said something about MapReduce.
Yeah, Amni, go ahead.
You said the programming is done only on a certain block, right? But what if there was an update on that block, or what if we did an update on that block and that block uh, uh, there is some issue with that block, and that block will that update be done on all the blocks or just one?
Yes, yes. So everything will be, name node maintains in such a way that every time there'll be 3 copies of the block that are maintained. If any of the machine goes down, immediately it's going to instruct the other data node to bring up one more copy of that particular block. So it's the responsibility of the name node to make sure that there are always 3 copies maintained for each and every block.
Okay.
Okay.
Yeah.
Yeah.
Thank you.
Yeah. Anybody have any other questions, guys?
No, I'm good.
Okay. Okay, I think I would be uploading the recording of this session along with the PPT and interview questions and everything. So I would need your email IDs. Can I have your email IDs? Can you put your email IDs in the chat box?
Yeah.
Yeah. So I got the email ID from Neil, from Anand as well. And Yamini, can you send your email ID? Okay, I got it. Anybody have any other questions, guys?
Good.
Okay, I think we are good then. We'll catch up tomorrow then. Bye. So please make sure that you set up Cloudera Quickstart VM. If there are any issues, just let me know. So just in case if you want to get in touch with me, so this is my WhatsApp number. I'm just noting down here. I think I don't have Anand's number. So Anand, probably you can ping me on this number on WhatsApp. So just in case if you face any issues while setting up Cloudera Quickstart VM, so we can sync up.
Yeah.
Okay. So that's all for today, guys. So we'll meet tomorrow again. So please make sure you have your Cloudera Quickstart VM up and running before tomorrow. See you tomorrow then. Bye. Bye everyone.